This is the second in a series of videos on Chapter 9. We're going to begin with the second searching technique called a binary search. And a binary search is a category of algorithm that is often called a divide and conquer algorithm. Because behind it, it says if I'm given n things to search, I will try my best to break the problem into half, so that I will say I don't need to search all of them. Let me just find out which half I need to search. The prerequisite for a binary search is that you must have a sorted array. If the array is not sorted, this will not work at all. And the strategy is to divide the array into three parts. One part is a single element that lies in the middle, and that's where we'll go into the array to begin the search. Then we will have all the elements that lie on the left of the middle element, that come before the middle element, and all the elements that come after. Because after we do some checking, we will decide which side of the array we need to search, to continue to search. And think about it. So if you start off with 8 things to search, you might end up with 4 things the next time, and 2 things the next time, and 1 thing the next time. And it's pretty clear if you get down to just 1 thing, we're able then to answer the question, yes or no. All right? So that's the algorithm. So let's take a look. If we're looking for a key of 11, how do we do it? We go to the middle element. Well, where's the middle element? It turns out the middle element, in this case, we got lucky, is the 11. And then I say, I'm looking for the key 11. I will compare it to the middle element. It is an 11, so we can stop with success. Let's try another search. If we're looking for a 3, what happens? We always start in the middle. Where's the middle? Here. And you say, is 11 the key we're looking for? No. If it's not the key, then the algorithm says, let's see which side of the array we want to search. Notice that we have divided the array into a single element, all of these elements that occur to the right, and all of these elements that occur to the left. Now, which side do we want to search? Well, in this case, we really want to search on this side. So the next time we search is we take this list of shaded and go to the middle of it. What's at the middle of it? The 3. All right? And it happens that the element that's stored here matches the search key, and we can stop. Get the feel of this? Now let's see what happens when we do a 20. Well, when we do 20, where do we start? At the beginning. All right? Is 20 11? And 11 the same? No. So we've got to decide which side do we search on. Well, we clearly don't search on the left side, because the left side, everything on the left side is less than 11. So the only possible place to search is on the right side, because everything there is greater than or equal to 11. So I start at 11, then I will go to the middle of this, which is the 23. And then I will say 23. When I do 23, all of a sudden I now divide this list into the middle, the part that's on the right, part that's on the left. The part that's on the left is how big? It's just one element, 17. So when we look at the 17, we will say, is 20 17? And the answer is no. We're down to one element. We can say for sure that 20 is not in the array. Get the hang of that? Good. Now, here's a recursive algorithm. A recursive algorithm is a function that calls itself. But isn't that what we said we would do? We would search the whole array by going to the middle, and then if the key is not the middle element, we will pick which half of the array to search. How do we search the half of the array that we search? We search it the same way we search the whole thing. So we'll apply the binary search approach to either side that we pick. Now, let's ignore this for a moment, and now let's do this. The calculations we have to make is we must calculate the subscript that represents the middle element. And a couple of things to notice, Notice first of all that with the array, I must say what's the first subscript in the array, what's the last subscript in the array. So that at any time I'm searching a part of the array, pretty much never the whole array. So what do we have here? We go to the middle, we compare the middle to the key. If it matches, it's true. Otherwise, we have to decide which half of the array to search. In this case, if the key is less than the middle element, it means we need to search the left side. Where's the left side? The left side is the array that starts at the leftmost subscript, and it goes up to the middle element, but not quite. It's one short of the middle element. So this is the left side. Otherwise, we're going to search the right side. Notice a couple things. What is binary search? It returns a Boolean value, true or false. So let's say it this way. If the key doesn't match, I will return whatever answer binary search gives when I search the left side, or I will return whatever the answer binary search gives when I search the right side. All right? Now let's talk about this briefly. Whenever we have a recursive function, it's not looping, but it's a form of repetition, and it's a form of repetition that you must quit. You must have breaks. You must stop this, otherwise it will totally run away with you. And I'm giving you the clue here, and when you do the exercise I'm giving you, it will become clear why this is the right set of breaks. If for some reason the array gets inverted, where the subscript for the low happens to be bigger than the subscript for the high, it really means you've exhausted the array completely, and there really are no more elements. There's no such array that begins with subscript low that is bigger than the subscript high. Okay, so let me stop here, and the next video will be on the exercise that I want you